Immunomagnetic trapping microwells for human lymphocyte observation and whole blood processing. Motivation. Microwell trapping allows for cell observation for extended period of time, provides sufficient nutrients for long-term cell cultivation. Whole blood processing is an integral part of clinical diagnosis, allowing for lymphocyte counting and cancer cell detection. Numerical simulation predicts and optimizes device performance beforehand. 2. Microfluidic device specifications. This is the device parameters. These are the well parameters. This is the magnet used in our study. These are the magnet parameters. These are the modules used in our simulation. 3. Theory. The forces imposed on the cell are gravitational, drag, and magnetophoretic forces. By using COMSOL, the laminar flow and solid mechanics can be solved for using the Navier-Stokes equation and the fluid-solid interaction. 4. It felt particle density on trapping. For single bead, trapping was successful. For two beads, the first bead collided with the ceiling due to increased lift force. For missile stress increases due to higher flow rate between the two beads. 5. It felt velocity on trapping. Number of subregions increases with flow velocity. However, the height of each subregion decreases. This increases particle throughput in microfluidic device. Dispersed regions for higher velocities prevents bead-bead interaction. 6. Effect of periodic magnetic force. For constant magnetic force, throughput was lower. Moving the magnet back and forth during experiments is shown to improve trapping capability. This is the result of constant magnetic force. This is the result of a periodic magnetic force. 7. Trapping of labeled cells. Simulation lymphocyte trapping with dynabeads. Shear stress increases with the number of beads. This is due to increased magnetic torque on the cell. 8. Whole blood processing. This is the mesh used for erythrocytes. This is the mesh used for platelets. Most clinical applications require processing of blood samples from patients. It is in our interest to develop a system that can accurately differentiate between labeled and unlabeled cells. 9. Conclusions. Immunomagnetic trapping is more specific than hydrodynamic trapping. A periodic magnetic force is used to improve trapping efficiency. By using a fully coupled solver and modifying the automatic remeshing process, it is possible to simulate the trajectory of any given particle. It is demonstrated that the feasibility of a whole blood processing simulation. Future applications of microfluidic devices include immunomagnetic-based cancer cell detection and lymphocyte counting. Thanks for your attention.